Volkswagen diesel engine from the 1990s fit into a Japanese K-van? If so, what does it take to make that work? Will the powertrain be reliable after you do a lot of unusual things to make it fit in the Subaru Sambar? For example, installing the transmission upside down. Also, rerouting the oil filtration and cooling circuits. I set out with a weed whacker, a Q-tip, and 40 pounds of Instagram likes to find the answers. In the last video, you saw that the engine ran, the transmission seemed okay in the inverted configuration, and I confirmed that the turbocharger and the head were receiving oil flow. This was not a given because I was using a homemade oil distribution manifold in order to clear the relocated drive axle. You also saw that the oil destined to lubricate the turbocharger was aerated, and you saw me inspect the oil pump as a possible culprit. While the oil aeration may not have been caused by the original oil pump, that pump needed to be replaced. While waiting for a replacement oil pump, I noticed that my custom oil manifold was still weeping oil. At this point, that iteration cannot be saved, so I'm building another one while remembering the lessons learned. 3/8-inch steel base plate to reduce the possibility of warping when welding, and a new method of attaching the AR oil lines to the manifold. When brainstorming how to make this new design work, it occurred to me that I had another flaw in the prior design. Contrary to my assumption that the check valve would not be necessary, it does need a check valve. You might remember that the original oil filter / oil cooler attachment device had a one-way check valve, which I surmised prevented the oil in the galleys feeding the head from draining back down into the pan when the engine was not operating. I believe that check valve existed to eliminate the time needed at cold start for oil to leave the pump, traverse the oil cooler and filter, and then flow up the internal oil galleries to lubricate the cam and valve train. You may also remember that the filtered and cooled oil was distributed to 2 ports on the side of the block, one to the crank and bottom end, and one to the head. Because I had both of those delivery ports connected to the same sub-manifold, oil from the head could drain back into that little sub-manifold, into the port which feeds the bottom end of the engine, and ultimately drain into the pan. I'm glad I realized this mistake before putting this powertrain into service. So the new design will incorporate the original check valve. I had planned to powder coat the manifold, and I have a cheap powder coat sprayer from Harbor Freight. I've been wanting to try this textured powder coat, and I finally have the opportunity. I really like the finish, though I did not apply it as thick as I should have on the crankcase breather port tube. Still, I like it, and ultimately, I'm seeking rust protection, not beauty. I've cleaned the check valve and used some blue Loctite, that's medium strength, to secure the check valve into the threads so it can do its thing. This will probably help the longevity of the engine over time. I recently moved to a new location, and in doing so, I gained this wonderful workspace. You see it in all the Sambar Volkswagen TDI engine swap videos, and I'm very fortunate to have this space. However, it's not perfect. The ceiling height is too low for a lift, and without a lift, I must put a lot of thought into the swap process prior to starting. Low-hanging HVAC components must be avoided, and I had to plan how I would position the new powertrain under the chassis, then lift that powertrain up into position. Engine and/or transmission installation and removal has to be done from the bottom of this vehicle. The engine hoist I have is not going to be a great option for that, so here's my plan. Disconnect and lower the original powertrain onto a special table I built almost 2 years ago when I performed the engine out long-term service on this powertrain. When I'm ready to place the diesel powertrain into the chassis, I'll roll the chassis to the ramps. I will position the powertrain and its custom-built dolly under the engine bay and slowly roll the chassis down the ramps. I will get some help to keep pushing the dolly forward to keep up with the chassis, and the two should line up together as they move towards the end of the ramps. Once all 4 wheels are on the ground and the engine is positioned within the powertrain bay, I should be able to start the process of designing and building engine and transmission mounts. Custom engine and transmission mounts are a must because there are no mounts available which would secure this Volkswagen powertrain to this Subaru chassis. Not until the new powertrain is properly mounted and secured can I begin designing the ancillary connections, things like fuel lines, electrical wiring, and cooling lines. These should not be designed until I'm sure there won't be any changes to the mounting location. Any other items to be designed and fabricated, such as how a chassis with a cable-operated clutch will operate a transmission that's equipped with a hydraulically actuated clutch. Also, how the two shift cables will attach to this transmission. They're not designed to work with each other, so it will have to be a custom fabrication. Also, this vehicle will need a custom exhaust system. In short, there's a lot of work to be done if I'm able to mount the powertrain in a way that aligns with the drive axles. If I can't make the VW powertrain fit and mount in reasonably close alignment with the Subaru axle centerline, this project is over. Oh, and new axles will have to be fabricated. The Subaru axle shafts will not connect to the Volkswagen transmission. I will need to make drive axles that use Subaru CV joints on the outer part of the shaft, CV joints which will fit with the chassis suspension and hubs, but with Volkswagen inner CV joints, which will bolt to the Volkswagen transmission. Switching to the topic of the oil pump, there's good and bad news. First, the good news. The oil pump arrived and it appears to be the correct one. I dropped the oil pan to remove the old pump. An interesting feature of this engine is that the oil pan gasket is a combination unit which includes the oil windage tray. With those items out of the way, I could remove the old pump. I had always intended to powder coat the oil pan if it looked like I would be able to keep the stock oil pan. It does look like the stock oil pan will work, so now is a good time to apply the powder coat. So I stripped the temporary yellow paint, applied the powder, and baked it in my converted wall oven. Clearly, I did not apply the powder thick enough on the vertical sides of the pan, but that's okay. I will take this as a lesson learned for the next time I apply this material. Now for the bad news. In doing this, I found metal and detritus in the oil pan. For sure, it was not there before, as I cleaned and cleaned the oil pan the first time I had it off. So this material is new. I took a strong magnet and moved it around inside the oil left in the pan to gather as much of the contamination as I could. And I put that on a white paper towel so I could inspect it closely. Having this much metal in the pan after only idling the engine for about a minute is surprising. My hunch is that this is actually cutting debris I failed to remove from the oil manifold internals before I installed it. I did a lot of grinding, cutting, and welding on these manifolds, even though I thought I cleaned them out before I installed them. One thing I noticed when cutting with my tool is that the residue coming off the cutting disc would be magnetized somehow. The magnetized screwdrivers sitting on my workbench near the place I would be making my cuts collected grinding disc material on their tips, along with the metal shards from the workpiece. When I look closely at this crud, I believe I see dark bits that could be from the grinding disc itself. Time will tell if I'm right about this or not, but for now I'm going to assume an engine flush and oil change is all that is needed. Back to the oil pump replacement. There are only 2 bolts holding the oil pump in place. I also took the opportunity to look for signs that the detritus was from the crank or connecting rods, and I didn't see any obvious problems. Interesting just how clean the underside of the pistons are. I also noticed that this engine does have oil squirters pointing at the bottom of the pistons. Speaking of pointing, I am disappointed that I let metal shards and grinding disc residue into the engine. Now, you may already know about this, but I didn't. In Japan, it is common to use a technique called shisa kanko to reduce errors and mistakes. China also has a similar technique. The idea focuses one's attention on the specific thing they are doing or checking, making routine tasks more intentional. Studies show this technique delivers a meaningful improvement to accuracy and quality. After that screw up, clearly I need to do a better job, so I will be trying out this technique from time to time. So, new oil pump installed, oil pan powder coated, and revised oil distribution manifold is installed. In spite of the metal in the oil pan, I do not believe there is damage to the engine. Given that the engine only ran for about a minute and without load, I think it's likely this situation is going to be okay. So here I go. Setting up for powertrain removal on my ramps requires the rear of the van to be supported with jack stands and the wheels to come off. If this swap works, I plan to offer the Subaru powertrain for sale. I assume that that will include shipping the engine, which means I probably need to drain the oil at some point. Might as well do it now while it's easy to reach the drain plug. And in no particular order, I disconnected the engine ground wire, wiring to the ignition coil, and the air intake hoses. Next, I turned my attention to the cooling system. I pulled the recovery tank line to let the tank drain. One interesting thing about this van is the location of the coolant system cap. I can't call it a radiator cap because it's not on the radiator. As you probably already know, having the cap open and off is necessary to drain the system of coolant. Next, I shimmied under the van. Here you can see where the air conditioner condenser is mounted, and nearer the front of the vehicle, the cooling system heat exchanger. There's a white petcock with a handle which is used to drain the cooling system. I needed a hose to connect here to prevent coolant from splattering all over the place. I slipped on the hose and drained the coolant into a recovery pan. Then I loosened the alternator so I could remove the accessory belt. My plan is to leave the AC compressor connected to the high and low pressure lines and simply tie it out of the way somewhere. The alternator, however, will eventually go with the Subaru powertrain to its new owner. I disconnected the green control wiring harness as well as the black battery wire on the center of your screen. My attention to fuel lines now. One is fuel from the tank, another is excess fuel returned to the tank, and the third item here is to route gasoline vapors from the tank to a charcoal canister. As I disconnect lines, I'm plugging them with either bolts or with silicone triangles that are typically used for protecting orifices when applying powder coat paint. This is another fuel vapor line that dumps fuel fumes into the charcoal canister. This is a coolant line, and I assume that it's part of the cold start support components. Since this engine is carbureted, manufacturers had to get creative to encourage the engine to run in cold temperatures. Like modern electronic fuel injection, where the computer checks the outside and inside temperatures and adjusts the fuel ratio and idle point automatically. That wiring connector is the signal system to activate the backup lights when the transmission is shifted into reverse. And this wire is connected to the coolant temperature sensor, and it provides information about the engine temperature to the gauge on the dash. Here I disconnected the wiring harness from the air conditioner compressor and took off the cover plate that shields the throttle linkage and cables. This is, I believe, the coolant line which returns liquid from the radiator after it has been cooled. Disconnect the starter motor signal wire and the power wire. Disconnect the coil wire from the coil. Disconnect more wires from the coil. I'm not sure what these do. And remove 2 bolts that hold the exhaust system up. More wires to disconnect, and again, I don't know what this does. It does have a vacuum line attached to it. This hose connects to the distributor cap and runs into the body. It's for ventilation when the air in the distributor cap gets hot. While I was here, I noticed a drop of oil on the distributor base, so there must be an oil leak in the area. I also noticed a spot of oil on the oil pan, but that could have been from draining the oil yesterday. I needed to disconnect the cable that engages and disengages the clutch and remove two bolts that hold the cable housing to the transmission. With that out of the way, I can see that I need to disconnect the upper shift cable, and I'll have to remove the airbox before I can get to it. While I was under the van, I switched over to the driver's side. I needed to disconnect more of the wiring harness, and this is the oil pressure sending unit. Nearby was another coolant line. This one seems to go to a sealed tank, which I assume is there to capture air bubbles in the coolant lines. Back to topside, I needed to disconnect wiring going to the carburetor. I believe this powers a solenoid that increases the engine idle when the engine is cold or when the air conditioner compressor cycles on. I needed to disconnect another hose that connects the carburetor to the previously mentioned charcoal canister. Aside from the electrical connections, the belt, and the low and high pressure lines, there are only two bolts holding the air compressor on. To access one of those bolts, I needed to take the splash shield out of the wheel well. This will also provide more room to pull the axle shafts out of the transaxle with a slide hammer when that time comes. Going back to the top side, it's time to pull the air filter box so I can disconnect the second shifter cable that's underneath it. Here's a quick peek showing where the shifter cable attaches. Then I disconnected the speedometer cable. Here's a slightly better view of that cable. Cap it off. I need to disconnect the bracket which holds the shifter cable housings to the transaxle. At this point, I think I have everything disconnected, but there was one item that I neglected, the throttle cable. Now at this point, I turn my attention to the bolts holding the powertrain in the chassis. I always remove the rear crossbar with the powertrain because it seems easier to do it this way. As you can see, there are two bolts on either side of the crossmember. Additionally, there are two horizontal support bars that have to be removed. There's a second item I forgot to disconnect. This. I think this is a sensor that activates a light on the dash if the catalytic converter overheats. Let's have a look at the forward transmission mount. There are 4 bolts attaching it. I took 2 of them out while leaving 2 in to be sure that the powertrain didn't rotate or fall while I was under there. I realized I could access them from the side if I put all of my 3/8 extensions together. So now I'm in the home stretch, and there's nothing left to do but do it.